we're going to jump straight in. We started with the exam on Monday, and we got up to question 2.2.1, where I then had my moment and said that 111 was a prime number when it is not. So what we had spoken about is just a little bit about fractions, and we'd spoken a little bit about types of numbers. I'm hoping that I've kind of figured out my pen situation. So we're going to see what happens. It might work, it might not, but let's see what happens. We're going to try to finish off this question 2.2, and then we're going to keep going. Question 2 is really the important question that I want to focus on. But we'll see how we go. And for those of you, I didn't mention it on or in Monday's lesson rather, please don't think that we're going to sit here for a full hour. I will give you a break halfway through. So you're not going to sit for the full hour doing maths. We have a brain break halfway through, just because, you know, to concentrate for an hour is quite hard. So at about 5:30, we will take a little break and then we will carry on, just that you are aware. And yeah, you can use that time to have a stretch, run to the loo, or whatever you might need. Okay. So guys, our next question that we're on is question 2.2.2. Remember, we are using the list of numbers that I've highlighted in blue up here. And this question is asking us, let's maybe choose a different color here. This question is asking us to select from that list a number that represents or that is an improper fraction. So take a look at those numbers again. We've got 21, 36, 111, 3/4, 19, 12, and 4/3. So does anyone want to have a go and tell me which one of those is an improper fraction? And you can put it in the chat or you can raise your hand. I don't really mind. Takalani, which one? Maybe I need to ask.
Improper 4/3 is the improper fraction.
Excellent. And how do we know that's an improper fraction?
Because you
can say top and bottom.
Ma'am?
You can say top and bottom if you want.
Okay, ma'am. The top is bigger than the bottom.
Excellent. Well done. So guys, that's how we can identify an improper fraction for ourselves. When the top or the numerator is bigger than the denominator, that is when we know we have an improper fraction. That's obviously a very weird spelling there of numerator. So let's try that again. Numerator. So when that is greater than or bigger than the bottom, which is the denominator, we've got an improper fraction. So here, our improper fraction is 4/3. And remember, we spoke about fractions representing parts of a whole. And whilst improper fractions still do that, improper fractions, because the top is bigger than the bottom, represents more than a whole. So it represents a whole and then a little bit extra. So if we imagine this as like a visual or like a picture, let me try that picture again. Clearly not an artist, it's fine. Okay, I didn't really get better, but it's okay. If we imagine this as something visual, 4/3. Now 4/3, we know we could convert to a mixed number, and that is then 1 1/3. So this 1 represents a whole. It's 3/3, or 3 parts of a whole. And then we've got a little bit extra, the 1/3, that is represented by the fraction part of that mixed number. And so improper fractions represent parts of a whole, no, let me say that again, represent a whole or wholes and then a little bit extra. So that is, it's still a fraction, or it's still a type of fraction. It's just a little bit different in terms of what it represents. Excellent. Okay, so the next question, 2.2.3, is asking us, what is the smallest common denominator of the two fractions 3/4 and 4/3? So my first question is, what do I mean when I'm asking you for a common denominator? Like, what am I asking you to find there? You can, again, put it in the chat, or you can raise your hand. I don't really mind. Thank you, my love. Sorry, guys. I had to get some medicine from the pharmacy. Anyone? What am I asking for when I'm asking for a common denominator. If that's stumping you a bit, let's take it back. Does anyone know what I mean when I say a lowest common multiple? What is the lowest common multiple? Laura?
Ma'am, a lowest common multiple is like something, so like it's when you have two numbers, for example, 6 and 3, then they both have like one number that is in both multiple things.
Okay, perfect. Okay, so this is one where we're looking for something that's common between two values that we are working with. Sometimes it's two values, sometimes it's English today. Sometimes it's two values, sometimes it's more than two values. But as Lara says, basically what we're looking for here is something that's common between the two. Okay, so lowest common denominator comes from the concept of lowest common multiple. Now, if you remember this beautiful thing that's going on here, those are multiples of 2 and 3. And so if we take the denominators that we're working with, 3 and 4, and we start listing the multiples here, we can see which is the lowest common one. Now, remember, multiples are basically your times table. So the multiples of 3 are 3, 6, 9, 12, and so on. And then your multiples of 4 are 4, 8, 12, 16, and so it keeps going. And so this goes back to what Laura said, we're looking for that common value between the two. Now, importantly, we want the lowest common value, that L is lowest. And so what we see is that the smallest number that is common in terms of the multiples of both 3 and 4 is 12. And so when we now start to look for that common denominator, a way to make these denominators the same, my common denominator here between the two is 12. I can go and make both of those denominators the same by making them both 12. And remember, we spoke about the fact that finding a common denominator allows us to do many things. One of the things that allows us to do is compare fractions. It tells us, or it lets us figure out if one of the fractions is bigger or smaller than another. It also, when we eventually start doing fractions, it allows us to add and subtract fractions. So obviously we've got a calculator, we could just put it into a calculator, but if we're asked to add and subtract fractions without a calculator, we have to find a common denominator. That's the only way we can do it without a calculator. And so this concept of a common denominator is very, very important. So again, it's the smallest number that both denominators, so in this case, the 4 and the 3, could divide into. And this is then our multiples, our times tables. Here, we all good so far? You can just put a little thumbs up in the chat. Are we okay?
Yeah, let's see. Yeah, following. I see some thumbs up. Yes, Nicky. Yes, Lara.
And guys,
that's
remember
good that y'all are following.
If at any point you have questions, please do use the chat or please do raise your hand. Okay, I know this is still grade 8 revision, but this is the stuff we want to make sure we're happy with before we move on to the grade 9 stuff. Okay, good. We seem okay. Excellent. Right, so our next question, hang on, let me stop there. Tingo, do you have a question for us?
Ma'am, I was late for class. Would you please mind explaining it?
What exactly do you want explained?
Everything for the revision. I was late.
Okay, so I'm not going to explain everything because remember the lessons are recorded, so you can get the recording there. I'll quickly go over what we have spoken about, but luckily we haven't done too much, so you haven't missed a lot, so don't stress. Okay, so the first question that we looked at was 2.2. We wanted to know which of the numbers in the list up here was an improper fraction, and we spoke about the fact that an improper fraction is where the numerator is bigger than the denominator. So that gave us our answer of 4/3.
Yes, ma'am.
In 2.2.3, we were looking for a common denominator, and a common denominator is basically now where we need to look at common multiples of the two denominators. So that's why we listed our multiples on the side here of those two values to find the smallest one that was common between both. And then, like I was explaining, this is important for multiple things when working with fractions. Okay, and guys, just a reminder, if you do miss anything, it is recorded, so you will be able to get the lesson online. Alrighty, so let's have a look at 2.2.4. So 2.2.4, oh golly, chaos, is asking us, or rather is giving us, a list of numbers 1, 2, 3, 4, 6, 9, 12, and 18. And they are asking us, what number are these factors of? So let's start with, what is a factor? If I say the word factor, what do I mean? What does that mean? And you can put it in the chat, or you can raise your hand. What are factors of a number? We know what multiples are now. What are factors? Anyone, what do we think? I know we're refreshing a lot of stuff from last year. Kimikli, nice try. Remember, we've spoken about multiples, and multiples are basically your times tables. Factors are a little bit different to that. Okay, guys, so factors, and don't stress if we aren't 100% there yet, that's okay. We are going to do a whole lesson on factors coming up in our next course, so don't stress. Factors are basically numbers that we can multiply together to get a product or to make a number. So let's say, for example, we were looking at factors of, or we were looking at the number 12, okay? So if 12 is our number that we're looking at, and we want the factors of that, basically we want to know what numbers can I times together to get 12. So one of those pairs, as we know, we could say 1 times 12, that gives me 12. I could also say 2 times 6, that gives me 12 as well. And I can say 3 times 4. All of these are then, oh, that was a weird looking, whatever that was. All of these are then factors, panic, are factors of 12. Oh, we were doing so well here for a second. Factors of 12. Okay, so they are the numbers that we times together to get an answer. So if we look at these numbers that we've been given here, the 1, 2, 3, 4, 6, 9, 12, and 18, when I multiply them together, what numbers am I getting? So one way that we can do this is we can say, okay, well, I've got a whole bunch of different pairs of numbers here going on here. So I've got the biggest factor here that's been listed for me of 18. Now, the smallest one is the number 1. Now, we obviously know that 1 times 18 gives us 18. It's fighting with me. I'm not going to fight with it. But we also have a factor 2 here. There we go. So looking at this, if we multiply 2 and 18, so 2 times 18, we get 36, which tells me that potentially all of these numbers listed here are factors of 36. Okay, and Dile's put a really, I'm going to carry on with this question now, but Dile's put a really nice definition of factors in the chat for us. It is a number that divides into another value without a remainder, and that's quite important. It mustn't have a remainder. If it has a remainder, then we've got a bit of a problem. Okay, so now what we want to do is we want to check if all of these numbers listed here can divide into 36. Well, 1 can divide into 36. We know that because 36 divided by 1 is 36. 2 can divide into 36. So can 4, so can 3, so can 6, so can 9, so can 12. And so that then means that all of these numbers listed here are factors of the number 36. We can times them together in some pair to create the number 36. Okay, so factors again are numbers that we can times together to get another number. And factors are very important. From about grade 9, you're going to use the concept of factors quite a lot. We are going to do a whole nother lesson on factors, so don't stress too much. but it is very important that we know the difference between factors and multiples. And again, we're going to do a lesson on both of those, so we will recap that next week, or in the next course rather. Right, I'm just waiting here in case anyone wants to take a screenshot of these answers, and then I'm going to move down to the next question.
Very colorful answers. So yeah, if you take a screenshot, definitely you'll understand when you want to go back to this.
Okay, guys, so let's have a look at the next question, 2.3. So 2.3, we're now working with operations, dealing with numbers, okay? So we've got these numbers here, 6 plus -8 plus 2, plus -2. And what sort of has been tested here, what has been asked here, is that you understand how negative numbers affect the operation of an expression, or affect the value of an expression. Okay, now, again, you have a calculator, and for the most part, personally, I'm fine with you using the calculator. You're going to eventually use a calculator all the time, so why not start? But I know some teachers don't like you to use calculators just yet, and so we need to be comfortable being able to do these calculations without a calculator. Now, some of you will be able to look at this, know exactly what your answer is, write it down, no problems. However, like I say, negative numbers do create problems for us sometimes. And so we need to have tools that allow us to deal with these negative numbers. Now, one of these tools is to have a number line. So I've drawn a number line here. You can draw one if you want. But let's use this number line to figure out what this expression is saying to us and how we can use it to go and add and subtract these numbers. Now, there's a couple different ways you can deal with this, but I can see that my starting point here is +6. So I'm going to start on my number line at +6, whoopsie daisies, because that is where I'm starting with this whole expression's operations. So here I am at -6, +6. My pen was working so well, and now it's just going to fight with me. Right, +6. The first step in my operation is to add -8. Now, can anyone tell me what that actually means? If we've got a plus and a minus next to each other, what operation do I actually work with there? Am I going to +8 or am I going to -8? You can just put it in the chat if you want. What operation is important there for me? Takalani, which one?
Ma'am, you're going to use the negatives, the minus.
Excellent, well done. So guys, when we have a situation where we've got a plus and a minus next to each other, we know that when we multiply a positive, it's all just gone badly. Let's try that again. We know that when we've got a plus and a minus right next to each other, that essentially means that we're multiplying those two signs. And we know that when we times a positive and a negative, I get a negative. So exactly, we are going to deal with the -8. And so now what I want to do is I want to go to my number line and I want to take 8 away from 6. Now that means I'm moving towards the negative numbers here. So I'm moving to the left. So when I subtract this 8, 1, 2, 3, 4, 5, 6, 7, 8, I end up at -2 on my number line. So that's the first sort of operation done and dusted in this expression. I now need to go from whatever that answer is and add a -2. And as we've just been told, when we have this situation of a plus and a minus together, I'm working with the minus. So what this is telling me to do is it's telling me to subtract 2 now. So I want to go to my number line and I want to subtract another 2, and that ends me at a -4, or I end up at a -4. So the simplification of this expression is an answer of -4. Now, again, some of you might have been perfectly comfortable just doing that in your head or not needing to have a number line with that. Some of you might have used a calculator. But it is sometimes important for us to not rely on a calculator, because sometimes we are asked to do these calculations without a calculator. And so it is important that we're able to do it without. A number line is a very useful way to work with positive and negative integers, or whole, like numbers without fractions. And so if you are struggling and you have to do something like this without a calculator, just draw a very rough number line for yourself. Okay, it is very helpful. It doesn't have to be a beautiful number line, literally just a little scribble on the side of your page to help you if you struggle to do these without a calculator. Okay, so again, I'm going to wait 2 seconds for you to take a screenshot. I just want to remind everyone, we get that there's load shedding, and I know it's at stage 6 at the moment, so it's really not convenient. If you guys are in and out of the lesson, it's okay. Please don't worry. As I've said, these are recorded for you, so you will be able to get the recording tomorrow earliest to rewatch this lesson so that you're not missing out on anything. Okay, we get that it happens, so please don't worry at all. Completely understand. Cindy, do you have a question for us?
Ma'am, when when do you post the videos?
So they've all posted within 24 hours of the lesson. So this video should be posted tomorrow.
Yes.
And also, where do
definitely
you
will
get
happen.
them?
Okay, so the videos you can get on Watobe's website. So if you go to, I'm pretty sure it's watobe.com, and then there's a little tab at the top that says classes. If you click on that and you go to grade 8, all of the videos are there for you.
Okay, thank you, ma'am.
Pleasure. Okay, so guys, Cindy's question is actually a really good question. So what I'll do in our next lesson on Monday, at the beginning of our lesson, I'll actually just show you how to navigate the website so that you can see where to get these videos, okay? Because I know it for some is a new system. There we go. There's also the Watobe app where you can access all of the videos. Okay, I'm assuming we've all taken screenshots. So we already are halfway, which is awesome. So we're going to do our brain break. Sorry, my brain break is up here today. I don't know where to put it, so it's here. Okay, so remember, we haven't done a brain break yet. So a brain break is basically where we take like a couple minutes from our lesson. We do something a little bit different to what we're dealing with. Generally, it'll be like a maths puzzle or like some sort of puzzle problem, something like that. And we give it a try. So this is our first brain break. So what we'll do is we'll do this one together, but we'll mix it up every now and then to do something a bit different. Now, guys, your brain break is a time for you to, if you need to get up, stretch, run to the loo. I do encourage you to try these because, again, even though it seems like something silly, it's creating number confidence by doing these things. Okay, so there is a reason and there's a purpose to all of this. Remember, I've said you will always have a joke of the lesson. So my joke today is a cow joke. A cow in an earthquake is called a milkshake. There'll be lots of cow jokes, so you'll get used to it. You don't have to find it funny either. This is really my sense of humor with cows. Okay, so this brain break, what we want to do is we want to look at the pictures that we have here, and I'm sure most of you have seen these before, and we want to figure out the value of each of the boots, sunglasses, and coats in order to work out the value of this final sum at the bottom here. So you can really approach it however you want, but what I try and look for is an expression or a step or one of these 4 lines where we're working with the same image. So in this first one here, all of these, I don't know what that was. It was trying to be a curly bracket, but it didn't become a curly bracket. In this first one here, all of these are boots. So I'm adding exactly the same value 3 times to get the number 42. So my question to you is, how can I go and work out what 2 boots is worth, knowing that when I add 2 boots plus 2 boots plus 2 boots, I must get 42. And Adile is already on it in the chat there. So Adile said to us that if we add 14 3 times, so basically saying that if each of these pairs of boots are worth 14, my pen was working so beautifully and now it's just hating on me. If we add 14 plus 14 plus 14, we're going to get 42. And they have to all be the same because it's exactly the same image. Now, what's really important here is this is 2 boots. And I need to take note of the fact that in my final expression, I only have 1 boot. So does anyone want to try and tell me what the value of 1 boot would be if we know that the value of 2 boots is 14? So what is 1 boot worth? And again, guys, when we're doing this, if you want to raise your hand and talk, please do feel free. Excellent, those of you on the chat. Tingo, Takalani, Shami, well done. We have got a value of 7 for 1 boot. So we would just halve it. Okay. So now we know that each pair of boots is 14. And what that means is now we know that the value of it, well, the value in my next step of this boot over here is 14. Now, what we also need to be careful of are the operations. Here I've got a plus and a multiplication. So something plus exactly the same thing times the 14 must give me 150. Now, when we are dealing with this, this is where bodmas or your order of work needs to become important. We know that we always have to start with multiplication. So just bear that in mind when trying to figure out what the sunglasses are worth. Remember, there's 2 pairs of sunglasses here, but I'm going to give you a second to have a try, have a think. What do we think this 2 pairs of sunglasses should be worth so that I get 150 for that next step? Okay, Tingo said 10, and I think I am tending to agree with that. Let's see why. So if each of these sunglasses are 10, the pairs of sunglasses are 10, if we do the multiplication first, we know that 10 times 14 gives me 140. And then if I add 10 to that, I get the 150 that I wanted. And so I would definitely agree the double sunglasses is worth 10. So in this final expression, we now know that those 2 pairs of sunglasses are worth 10. Now, what we need to be careful of is, again, in this third step over here, I've only got 1 pair of sunglasses. So given that 2 sunglasses is 10, how much is 1 sunglass worth? Sunglass, yeah. Nice, guys, well done. 1 pair of sunglasses is worth 5. So again, let's now go and figure out what the coat is worth. Be careful, your operations are again times and addition. So be careful of your order of operations or bodmas here, but try and figure out for me what the coat is going to be worth here. So again, you're multiplying and adding. So the coat times what plus another coat. What should those coats be worth to give us 54? Kaklecho, don't stress at all. Load shedding is harshing our vibe, so don't worry. You can get the video online if you miss anything. Guys, remember what we're trying to do is we're trying to find the value of the coats. And remember the operations that I have going on here is times and plus. I don't know what's happening here. So we want the coats. Anyone want to try to tell me what they think the coat is worth? Oh, we stumped on the last one. Okay, let's see. Well, you can do a bit of trial and error here, but basically, if we say 9 times 5, I'm just going to write it at the bottom here, we get 45. Well done. And if we then say 45 plus 9, we get 54. So 1 coat is worth 9. Now, again, we need to be careful on this last step. We've got 2 coats, which means that double 9 is 18. And so in this last expression, I know I've got a lot going on here, but it's all right. In this last expression, what we have is a sum that we need to work out the value of that says 7 plus 10 times 18. Now, again, guys, you need to remember your order of operations or bodmas here is very important. So we need to do the multiplication first before we do the addition. So I'm going to give you guys a chance to work that out for me. Remember, bodmas, very important here. And I'll wait for it to come in on the chat what we think the answer is for this final one. Laura, do you have an answer for us?
Yes, ma'am. 7 plus 10 times 18 is 100.
Say that again for me. You went a bit soft.
Sorry, ma'am. 7 plus 10 times 18 is 187.
Excellent. Well done. So guys, remember, we do the multiplication first. So 10 times 18 is 180. Your 180. And then we only add the 7. It's going to fight with me, so I'm not going to fight with it. And so we get 187 as our final answer. Okay, so guys, that's basically what we do in a brain break, a little maths puzzle, little maths trivia sort of thing for you to have a go of. If you don't get it, please don't worry about it. It's important that you try because, again, it gives you this number sense in working with numbers, but it's just a little break from what we were doing. So I don't know if anyone wants a screenshot of this. I will leave it up here for a second or two in case you do. Let me just do that so you can see the whole thing. And then we're going to go back to the questions that we were working on. Okay. Oops. Okay. It's just going to fight with me a little bit. Clearly, me and technology today are not the best of friends, but that's fine. Okay, so we are on question 2.4. Again, we're simplifying. I haven't given you a number line here, mostly because the operations are a little bit different. And quite frankly, I'm okay with calculator. But what is going to be important here is bodmas or order of work. I say order of work. Some people learn bodmas. I really have no preference of how you choose to remember it. Let's see if it's going to work for me here. No. Okay, so bodmas. Or we can say, and I'm not going to even attempt to write that out with my finger, or we can call it order of work. I call it order of work, but it's basically the same thing as bodmas. Now, guys, bodmas, remember, tells us the order in which we should do operations. So the B, does anyone want to quickly put on the chat for me, what does the B stand for? What should I be doing first according to B? Brackets, excellent. So anything, anything that is in brackets, we need to do first according to bodmas. Okay, so we can see already in the first expression or the first sum, I've got 2 pairs of brackets here. So I need to simplify what's inside those brackets first before I do anything else. Right, some people have learned bodmas. That isn't too important just yet because exponents doesn't really come up until grade 8. But basically, if there are exponents, that is the next thing that you would deal with. And then we go on to our operations. So does anyone want to tell me what the D, M, A, and S stand for in bodmas? You can raise your hand or you can put it in the chat. What do those last 4 letters mean? Masecha, what do they represent?
Ma'am, they represent D stands for division, M
Excellent.
stands for multiplication, A stands for addition, and
Good.
S stands for subtraction.
Good. Excellent. Well done. Okay, so guys, those are the operations that they need to follow after we've done the brackets. Now, what we need to remember is that division and multiplication sort of go together. So we should deal with all division and multiplication together first, and then we will deal with addition and subtraction. That is an aggressive size pen there. I'm sorry. It's a little bit much. Let's try that again. So multiplication and division go together. We deal with those two first, and then we go on to anything that is being added or subtracted. That is essentially what bodmas tells us. Order of work is essentially bodmas. It's telling me the order in which I should do my working out. So if we go to this first,
Sorry, Masichawa's hand is up. I'm not sure if it's a question before we move on.
yeah.
Uh-oh. It's got okay.
Right, so guys, if we look at our first question here, we can see that we've got 2 pairs of brackets. So like I said, we need to deal with those brackets first. So let's start with bracket number 1. Hands up, or you can put it in the chat. Who can simplify that bracket for me? So who can tell me what 14 divided by 2 is? Very nice. You see it coming through on the chat there. Excellent, guys. Well done. 14 divided by 2 is 7. Okay, so that's one of my brackets dealt with. The plus is going to stay there because I'm not dealing with it just yet. I'll get there. But now I need to simplify my next pair of brackets. So what is 51 minus 48? Now, again, if you need a little number line, draw a little number line for yourself. Do it on a calculator or do it in your head. I don't really mind. Taklani, what is 51 minus 48?
51 minus 48 is 3.
Excellent. Well done. So guys, that is the brackets part of my expression done. Now, essentially, because I've simplified those brackets, they actually fall away. And so what I'm actually left with is just an addition sum here, 7 plus 3. And I think you can all probably tell me with a lot of confidence that 7 plus 3 is 10. Excellent. Well done. Now, guys, it is super important that we follow bodmas. If we don't, we're going to get different answers, or we're going to get the incorrect answer. And that is just from not following the order of work. Most of the time, your calculator should do bodmas. Sometimes things go weird. And so when in doubt, follow your order of work or follow your bodmas steps so that you make sure you're getting the right answer. If you just do left to right without taking any, there's a word that I'm looking for, without taking note of what operation you're doing, you're not going to get the correct answer. So order of work or bodmas or bedmas, very, very important. Okay, again, I'm just stopping there in case anyone wants to take a screenshot. And then we're going to have a look at 2.4 here. Oopsie, who knows? Okay, so 2.4, we now have some fractions going on. Now, I've already said to you that the second you want to add or subtract fractions, we need to have a lowest common denominator. So I'm going to put a little note on the side here. When we want to add, sorry. To add or subtract fractions, we need an LCD, or lowest common denominator. Now that is super, super important. We have already done a question where we looked for the lowest common denominator between two fractions. That was in 2.3 somewhere. And so now what we want to do is we want to look at the two denominators that I've been given here. So it's a denominator of 3 and a denominator of 5 to find the LCD. Now, again, it depends how comfortable you are with fractions. What I would first do, though, is I would deal with this mixed number situation that we have going on here. Because mixed numbers, while some people prefer them to do working out, create a little bit of a problem. So what we want to do is we want to convert each of these mixed numbers to improper fractions. Now, can anyone raise their hand, or can anyone tell me, you can type it in the chat, it just might be easier to raise your hand. How do we convert from a mixed number to an improper fraction? There's a little trick that we can use. What is that trick, or what is the method to go and convert? Shami, tell me.
Um,
Oh, hang on, I think I muted you. I'm so sorry.
the method is to use the C method.
I've never heard of the C method. I'm intrigued. Tell me more.
So basically what you do, so I'll use the first part of the question. So you'll say 3 times 2,
Okay.
which equals 6,
Yeah.
plus 2, I think. Yeah, I think that's how
Yeah.
you do it.
It is. Why is it called the C method? What does the C have to do with it?
It's just, I'm not exactly sure, but yeah, just,
I wonder
yeah,
if it's maybe because they create like C shapes as you do it.
yeah.
Okay, cool. I've never heard it called that. I'm going to use that now. Thank you. Okay, so guys, Shami's beautifully explained that for us. The little trick to convert from a mixed number to an improper fraction is you take the denominator and you times it by the whole number. So this is a multiplication. And then you take that answer and you add the numerator. So we know that 3 times 2 is 6. And then we're going to add 2, which gives us 8. This is chaos. Right. This 8 is now going to become the numerator of my improper fraction. So this, as an improper fraction, is actually 8 over the original denominator of 3. So the improper fraction is 8 over 3. So I'm going to quickly give you a chance to go and try and convert for me the second mixed number, which is 1 2/5. So convert that for me to an improper fraction and tell me what you get. What is the improper fraction here, using the little C method that we explained? Okay, I see 2 answers on the chat, which look great. So remember, we're going to say 5 times 1, which gives me 5. And then we're going to add the numerator. So 5 plus 2, which gives me 7. And that is then over the original denominator of 7 over 5. And so what I've done here, guys, is I have now converted these to a form that's a little bit easier to use. So now I've got 8 over 3 plus 7 over 5. And this now is how I'm going to, from this point is where I'm going to start adding my fractions. So now what I want to do is I want to go back and I want to find that LCD that I spoke about. So look at these 2 denominators that you have. You've got a 3 and you've got a 5. And tell me, what is the smallest number that both of those can divide into? What is the smallest number that both 3 and 5 can divide into without a remainder? You're struggling, write out your 3 and 5 times tables and see which is the first one that appears in both. But I'm seeing some great answers. Nice, guys. So our LCD here. Shami, do you want to answer this?
It's 15. Yeah.
Excellent. Well done. Okay. So guys, that looks like an LCP, but it's supposed to say LCD. LCD is 15. And basically what that means now is I want to make both of those denominators 15. Now, in order to do that, I multiply. So I know that if I times 3 by 5, I get 15. But what I do to the bottom, I have to do to the top. So I also have to times the 8 by 5. I know that to make 5 15, I can times it by 3. But then I need to do the same thing to my numerator. And so the two fractions I end up with now the same denominators, I'm just going to go down here, is a fraction of 40 over 15 plus, rather, 21 over 15. And because I've got the same denominator now, it actually means that I can go and write this as one fraction of 40 plus 21 over 15. And this is why having an LCD is so important, because it allows me to get this one fraction that I want. And it allows me to go and simplify. So now all I need to do is subtract. No, I don't know why I'm saying subtract. All I need to do is add 21 to 40, which we know gives us 61 over 15. Now we always want to double check if we can simplify that. A quick way to do that is to just type it on your calculator. So if I type, I don't know if this can be backwards for you. If I type 61 divided by 15 on my calculator, woo, chaos. Okay, let's try that again. If I type it on my calculator, it gives me a fraction. Now, if that fraction is different to 61 over 15, my calculator has automatically simplified it for me. But because that answer has stayed 61 over 15, I can't simplify that any further. And so that is my final answer. And guys, again, we always want to simplify our answers. So the quick way to do that, quickly put it on your calculator and see if it gives you a simplified answer. Your calculator always gives you a simplified answer. Another way to go and see if it can simplify is to see if there's any number that can divide into both your numerator and denominator, and to then divide each of those by that. So for example, just in case that doesn't make too much sense, we just do a little block here. If I gave you the fraction 12 over 15, that can simplify because both of those numbers can be divided by 3. So if I divide 12 by 3, I get 4. And if I divide 15 by 3, I get 5. And so that is my simplified version of that fraction. But again, if I type 12 over 15 on my calculator automatically gives me the 4 over 5 as the simplified answer. Okay, so I'm gonna, again, leave this up in case anyone wants to take a screenshot.